So actually, as per the terminologies we saw last class, it is a new lexic that the T-SQL imposes to us, and we have to learn well. Briefly passing through, actually the T-SQL is a transact SQL. It is the technology itself. It is the adoption of the new way how to pass queries, how to pass SQL queries to the server and retrieve responses. Also, the CLI, it's one of the stored procedures that we may refer to, but it has to be actually from the server side. The triggers, it's another technology that we have actually to define. It is related. It's not related to the SQL Server only. Sorry for the interruption. Then the stored procedures, they are, as per the description of the CLI, they are stored procedures. They are things to be stored, but in the API level, it's not on the server side. It's in the API level. We talk about the SSDT or the SSMS or the Visual Studio, to be reused again and again and again upon the time of upon the lifetime of the project in question. Stored procedures. Database objects, they are the units that they hold data in the for deep background. Mainly we talk about the tables, but not only data objects. Memory overflow. This is actually a very famous word. It is a sort of a behavior via which we see actually the memory got stuck, and we are under attack or something like that. This is a scenario via which we overflow the limits, the buffer limit, where the data is required to be available for a program within the RAM memory. Bypassing that causes a memory overflow. This is an issue. This causes actually the computer fully to stuck, or the full program to stuck, or something like that. Unresponsive means. Stuck, it's a scenario via which we bring a process into unresponsive state. It is not responding. It does not produce anything. It does not behave completely. As we discussed the stored procedures, there are the extended stored procedures. Yet those are simple stored procedures, segregated, distributed stored procedures. We are not going to use a simple one block, one file that defines the stored procedure. We are going to use a multitude of stored procedures segregated geographically. We have 2, 3, 4 N computers. They are holding N APIs. Each API is holding a part. Altogether, they are interrogating a one data unit. Altogether, they are forming an extended stored procedure. Can you repeat this phrase, please, describing the extended stored procedure? Can you just present it to me again, please? Nihad, can you repeat this definition, please, regarding the extended stored procedure, the ESP? Nihad, the question is to you. Nihad, are you with me here or not? Okay, I believe you are not able to understand, and I will not say that you are absent. I'll leave it to the next question. The SQL CLI stored procedures actually is another sort of a stored procedure, but again, it's it has to be server side. In addition to a component that it might be a trigger, it might be actually a stored procedure itself from the API side. Means there is an interoperation in between the CLI server side and stored procedure API side. There is a full process to be happening. We give the example, and the example we are going to see it in this unit only. It is to integrate the use of the assemblies, which are the environment libraries, to be utilized by the project. So what we are going to define through the use of the SQL CLR stored procedures is the use of external libraries from the Microsoft operating system, for example. As per the example described in our book, we are going to use assemblies. We'll see that just in a while. So, in conclusion, SQL CLR stored procedure is an interoperation in between the API stored procedures and the server-side CLR. We define them here, CLR and stored procedures. So, interoperation between both, interoperation, I said again and again and again, it gives us the SQL CLR stored procedures. There is a specific behavior via which we have to define them theoretically and technically on real plane. First enhancement due to the T-SQL only, actually technically we are going to speak here, the table valid parameters, the TVP. It's one of the technological advancements that we may refer to generate types or user-defined types, to help in the generation of the user-defined functions, to help in the generation and the control fully of a stored procedure, let's say. All of them actually, they are behind of this small advancement. The context of the TVP is a scenario via which we reach to generate a new architecture of a type, something like that. So we define actually the type. I can give you the example. Int A. We are habituated with the saying of, for example, I'm going to type here. I'm going to type here to make you understand only. I'm going to type int. Let me write it in small. Int A. Can you see what I'm typing here? Then I'm going to type int B. This is in C++. I'm going to type C. All of them, they are types, data types. Using the TVPs will be able to generate user-defined types for the purpose of generating user-defined functions with a specific architecture. Specific architecture that has, yes, the capability to behave upon the need of the user and upon the need of the project in question. User-defined functions. TVP, table valid parameters. This imposes a security issue. This puts us in front of a security issue that we have to measure it. The overloading. The overloading. Because an overloading, it is opening a new entry point. Because an overloading, we're going to generate a new function, and the function might have an input point or a list of input points. So the system will admit that, and then it will allow the data to enter the system from that user-defined function. We have to be precautious at this level. Does not mean we don't do. No, we have to do, and if we need, we go for it. User-defined functions. Yet with a precautions, with considering the overloading constraints. With considering the overloading constraints. The benefit is to have actually user-defined function to be reused again and again with a specific architecture. It means the architecture actually we recognize it, so we defined it. We're going to use it again and again within the program or within the project in question. In addition to that, this architecture defined by the TVP, it is centrally maintained. What does it mean? It means if we have, for example, a program that has 100 lines of code, it has hundreds of pages, it is very big, enormous. Do we have to update all the architecture availabilities? No, we have to only update the definition of the TVP entity only one time, and everything will be updated. And because of this, it is said to be centrally maintained. Centrally maintained. We only need to update only the definition, and all the instances would be updated automatically. Centrally maintained. actually, and due to this definition, we are seeing a clear view when we compare it with the tables, with the regular tables. Syntax. Before we say or we dictate the syntax, we have to recognize that this technology, the table valid parameter, it is not only working upon the SQL server as per our book. No, we have the technology available in different platforms, like the Oracle. It's another it's another DBMS, professional DBMS, database management system, like the SQL server. But the syntax is different. It's not the same. See here, we are going to define a new user type architecture, but it is from int, not null. See how we did. Create a type. We give a name. This is user defined ID here. It's user defined. I may write whatever I want. I may write Oman. I may write whatever I want. I may write, for example, Nizwa. I may write GPA. I may write STDID. I may write STDID. It's user defined name. A variable, no? From what? From the data type we need. Very simple. In SQL Server, it's much more simpler than this Oracle, because we need to create an object in an Oracle. Here, no. Immediately you define a type and you give it a name, user defined. Then after, from what? The regular type. In this example, we generated two types, user types, two user types. One is from the int, not null. The second one is from varchar 100. And any place inside the program later on, if we type ID, the program will understand that it is int, not null. Or if you type location, the program will understand this is varchar 100. Is it clear? Is it clear?
Yes, it's clear.
That's great. That's great. One step further, actually, here in the Oracle, we are generating an object from something, actually, which is here the data type recognized by the Oracle. So we continue. Our reference is usually the SQL Server only because of the implementation and the framework to test, the test framework, sorry. What we saw here, it's a generation of a user-defined type. User-defined type. The section here, it is talking about table valued parameters. It is not only to generate an int type, but to generate a table as a type. The table means it has multitude of values. It has, for example, two ints, a list of students' GPAs, list. It is a table. A list of student IDs. It is a table. A list of student names. It is a table. We may generate that. This is the purpose here. For now, we only generated one value, let's say attribute or parameter. One value, not a table. Let's go on. Good. Here, by generating the table valued parameter, which is the multitude of values, the list of values, we will see actually the thing in a tabular way. We will be able to deal with this new defined table as if we are dealing with a normal entity inside the database. We may actually interrogate even this entity using the SQL commands. Yes, we can do that. Absolutely simple. It's a table at the end of the day. If it is available from within the server, so we can interrogate it using the SQL Server commands. Absolutely true. This is a common sense. Then there are other actually objects that we may deal with to do all the sorts of, let's say, concatenation or joining, or let's say search or something like that, or unifying, like the common table extensions, CTEs, or the temporary tables. Syntax to define that. Syntax to define the table as a multi-valued, let's say, parameter. We create the same thing, create type, the same scenario. Create type, we give the name, but here we are not going to say from int or from char or from varchar or from float. No. Earlier we did create type, give the name from. We choose the type. Here, no, we are not going to define it from, but we are going to give a table architecture. So create type. We give the name here in this example, customer user defined table, UDT. Customer. It's a name without space as table. Then in between simple parentheses, the architecture of the table. Here, this table has how many fields? 1, 2, 3. Field number 1 is an int. Field number 2 is an varchar. Field number 3 is an varchar. Any questions, please?
No, Mister.
No, Mister.
Means this architecture is clear. That's great. That's what I want you, and this is great. This is very great. Let's continue. Remember that TVPs, they are not the unique technology, and this is one of the technologies that we may refer to, and it can be dealt. We can deal with it as if we are dealing with an entity from within the SQL Server side only, and it can be utilized to. Yes, we may do a join. We may do actually an inner join, an outer join. We can do a unifying task with other tables, with common table extensions, which are sort of extensible tables. Also, they are a type of TVP, something. We can do an interrogation with those TVPs, no more no less. Actually, this is an abbreviation only. This is from our book. It is like that: table valid parameter, common table expression. We continue. Traditionally, actually, when before using this TVP technology from the T-SQL, sorry for the interruption. We used to, for example, we are willing to make an order, and we're going to see the details of the order with its details. We need to make two procedures or two requests. We submit the order, we execute the order, and we display the details of the order, the receipt, the invoice, things like that. This is with a traditional behavior. What does it mean traditional? Without the use of the table valued parameters. Means we are going to pass a query to the order table, then another query to the details table, and things like that. This is what it has to be done. Using a traditional program without the T-SQL enhancement, we will have to pass two queries or two procedures. The first one we terminated, and the second one we admitted. Now, in current technology, using the TVPs, and because of the TVP advancement, or because of the T-SQL enhancement, we may pass one procedure that has to do a multitude of tasks. One procedure that can interrogate different entities at the same time. Since we are using the TVP, a multitude of values. Syntax to create a stored procedure that accepts a TVP, table valued parameter, means we're going to generate a procedure that deals with a multi-valued entity, which is a table valid parameter, which is a TVP. Create a procedure, you give the name, and this name has to indicate that it is pointing to unit number 1, which is the order in this example, and the unit number 2, which is the order details also. Draw variable number 1. Let me maximize the view. I will return it later on just for your visualization only. This at order TVP, this is a variable, user defined. The at is the proof. The at here indicates that is a variable that is defined as this table. This is a table. This is comma. Here we have a comma. Second variable, user defined variable. How I knew? The at. This is a user defined variable that would act like as this table. They are only in red only. They will not modify the table. They will have the same architecture. They would have the same architecture. We come back to the slide. Architecture, here it is. They will have the same architecture. Architecture like what? The first variable, order TVP, it has the architecture of the order user defined table. The second variable, order details TVP, it would have the architecture of the order detail user defined table, order detail UDT, in read only mode. They will have the architecture without modification of this table. This one will have the architecture without modification, read only. Then it would insert into order whatever you want, and it would insert into order details whatever you want. Great. Then I said this definition inside still continue as what would do this procedure, this USP insert new order, this one. It would insert first, insert second. That's it. This is exactly from our book. Any questions, please? Great. So I believe that there is no question. So great. We continue. Yeah. The issues with such scenario here is that we are not able to make regeneration of entities in plural inside the DBMS, the database management system, or whether the database in question. Means, can we just change the architecture of the table by adding a field? No, we cannot, because we cannot pass the alter command. And usually it is in read only mode. Here it is. We'll find the read only at the end. Usually you'll find the read only. Here it is, the read only. To read only the content. So those are from the limitations of using a multi-valued parameter. It is not giving us 100% fluency. There are things that we cannot do, and this is an example. Okay, user-defined table. Sorry, the user-defined types. They are not the unique addition that this T-SQL has enhanced the environment with, but there are specific data types defined with the SQL server only. There are specific data types defined with this SQL server only. Means it will not. They will not work with any other program. Only if you are running an SQL server program. They are four mainly: the date, the time, the date time 2, and the date time of set range. So those are four data types. There is no order. This is the count data types. We use them whenever we need. We use any whenever we need. Those are four data types that they are actually understood by the SQL server specifically, and they are defined since the 2008 version or distribution of this SQL server. More than that, this is the explanation of what I was explaining you. Every variable you pass into an T-SQL statement, if you pass variables, you have to precede the variable with an at. So everything that comes after an at, no space, huh? If there is a space, there is a difference. So there is a problem. You have to be careful. If there is no space, or what comes after the at is a one variable name. After the at is one variable name. Have a look, please, at this slide. And do you have any questions regarding this written in yellow, this declaration, and those declarations here? Do you have any questions here at this level, please? Have a look well. Have a good focus on that.
No.
The others?
No, Mr.
Okay, great. Okay, great. I believe that it is very clear here. Here, actually, just one very final note. We are declaring. We are not creating. We are declaring. At the beginning, we created. At the beginning, we created a type. Here, we are declaring. We are not creating. Here, we are declaring. We are declaring a variable to hold the data type date. The second, we are declaring a variable meds at that holds the time. So later on we will not have to declare it again. We'll just immediately write the name of the variable preceded with an at. Whenever we need it, we use it. We will not redeclare it again. So this is the definition of, this is a declaration statement. This is another declaration statement within the SQL Server environment. I'll explain you a question and I'll leave you here at this level. We will meet next class for sure to accomplish. The architecture actually here is to extract the list of, let's say, matching products after a sale. We're going to sell list of products and update store, which is controlled by a stock entity. So what we have in stock, it has to be actually updated by the number of sales, whether an addition or a deduction, whether we are adding or deduction. This is a common sense understanding. So this is what I'm going to explain with the use of the merge statement. This is another enhancement that this T-SQL gives it to us, the merge statement. In this example, as I said, we are going to make a sale, whether it is an addition to sell or to buy, an addition or deduction. All what we do, if it is a sell, so we have to deduct from the stock. If it is an addition, we have to add to the stock. We added the value now. We add the value here to the stock. We deducted the quantity we sold, or the owner sold. So we have to deduct the quantity from the stock. It's a common sense understanding this story. How to implement it? We are going to use the merge statement here, which is actually a T-SQL enhancement. Any questions here, please?
No.
Okay, I'm going to explain you the assignment request. I need you actually to submit that. I'll tell the declaration, and later on I'm going to take the attendance also.